Hello, video 6 is called Energy Types, and the essential question is, what is energy, and how can I tell what energy types are inside of a system? So as we mentioned earlier, energy is a new variable. We use the letter E to represent energy. And the definition of energy is one of these weird, kind of fluffy things. It's the ability to make something happen. I know you've all used energy in your life. You know what it feels like to have a lot of energy or not to have a lot of energy. And when you have a lot of energy, you can do a lot of stuff. And that's a pretty good working definition for physics, too. In middle school, you may have learned about kinetic and potential energy. Actually, that was kind of like the first piece of this, but really kinetic and potential energy are actually categories. They're not actually types of energy. There's a lot more specific we can get when we talk about energy. So for this class, we're going to treat them as categories. The kinetic energy category includes all the kinds of energy that involve moving objects or big parts of objects. And the potential energy category includes everything that stores up energy any other way except for motion. No matter what kind of energy we are talking about, the units are the joule as far as the scientific community is concerned. But calories is another way of measuring energy. You can go back and forth between joules and calories as well. Just to have a sense of how much energy a joule is, stretching a rubber band would be a couple joules of energy, 1 or 2. Picking up a pineapple to a height of 1 meter would take 10 joules of energy, right? So we already know a pineapple is a kilogram. If you lift it up 1 meter, that would be 10 joules of energy. That spinning basketball or moving basketball probably has hundreds of joules of energy, and then a horse, of course, would have thousands or tens of thousands joules of energy. So those are all different kinds of energy, but you can have a sense of like that horse can make a lot more happen than the rubber band does, therefore it's going to have more energy. So in the category of kinetic energies, we've got any kind of energies, as I said before, where you have objects or pieces of objects are moving. So a couple examples, we've got a moving turtle, or we've got this, planet that might not look like it's moving, but there's lots of pieces of it that are moving as they spin around. So we're going to break the kinetic energy into a variety of more specific types, and I'm going to give you some examples of objects that would have a little bit of that type and objects that would have a lot of that type, so you can sort of start wrapping your hands around what we mean when we're talking about different energies. So the one you probably learned in middle school when they talked about generic kinetic energy, we're going to call EM, or motion energy. That subscript letter is going to help us identify the types of energy. So motion energy is just the movement of whole objects, and an object with a little bit of motion energy would be a turtle. And an object with a lot of motion energy would be a race car, right? Turtle can't do as much as a race car as far as making things happen. So that should kind of make intuitive sense, even if we don't have an equation yet to deal with that. Second kind of kinetic energy is rotational energy, or ER. So if we had a bike tire, right, it would be spinning. It wouldn't have motion energy because we're just holding the tire. The bike isn't necessarily moving. The tire isn't moving. It's just spinning. It would have rotation energy. A planet also doesn't appear to be moving. It's kind of staying stationary in space, but it's spinning, and that's going to be rotational energy. ET is going to represent thermal energy. The word thermal comes from the same root as temperature, and it has to do with the warmness or the heat of an object. Everything has some warmness, unless you are at a temperature called absolute zero, so nothing is that cold. Even ice is warm compared to some things. So ice would have a small amount of thermal energy, but still have some, and lava would have a whole lot because it's a lot bigger and hotter. EL would be light energy. Something with a very small dim light, like a flashlight, would have a small amount, and a really bright laser would have a lot. EW we're going to use for wave energy, and this is a broad category. There's a lot of things, but often when we talk about wave energy, we'll use things like sound, because sound is a wave. We'll talk about that in the next unit. But something like a whisper would have a very small amount of wave energy, and a different kind of wave, a water wave, but a tsunami would have a lot of wave energy. Potential energy, on the other hand, objects have potential energy if their shape or position stores up energy somehow, which is a little bit of a tricky concept to get the hang of. There are lots of types of potential energy as well. The one you probably learned in middle school that you called potential is actually, we're going to be specific and call it EG for gravitational energy. And we give things gravitational energy by lifting them further away from the center of the planet. So snow, for example, snow falling near the surface is very small and also kind of close to the center of or close to the surface of the planet, so it has a very small amount of gravitational energy. Whereas a space shuttle that's launched has a lot more because it's big and it's far away. Electrical energy is something we'll be covering more in the year, but you have a general sense of dangerous electrical wires versus ones that probably don't have as much electrical energy in them. A single electron has a small amount of electrical energy. A big high voltage power line would have a lot. Spring energy or elastic energy from stretchy things. And a rubber band would have a small amount of spring energy. Those car shocks that compress when your car goes over a bump, those would store up a lot of spring energy. Chemical energy is a super important one because it's actually the energy that powers us. Every time we eat food, that food has chemicals in it, and that's what actually is the thing that makes our bodies be able to do stuff. So a single peanut has chemical energy in it, probably not a lot. Another source of chemical energy for other devices is batteries. They store up energy in chemicals so that we can transfer that or transform that into other things. So a battery would probably have more energy than a peanut. And the last kind of potential energy is nuclear energy, or EN. Amazingly, bananas actually have quite a bit of radioactive nuclear energy. They have potassium in them, which is a relatively radioactive element, but still small in the grand scheme of things, compared to, for example, a nuclear reactor, which would store a lot of nuclear energy. Okay, so we're on our summarize slide. Please review that essential question, which is what is energy and how can I tell what kinds of energy are in a system? And I would encourage you to do things like go back through those types of energy and see if you can come up with another example of an object that has them, to see if you check yourself to see if you really understand it. Another thing to think about is why did we not have a tool to measure energy? Why is that sort of a tricky thing to do in science? And why is it hard to have the equation for energy? And those are questions that you'll ask yourself, and we'll get better at dealing with those. And if you really want to know, then we'll take more physics down the road, and we'll start doing some more complicated calculations with those. Thanks for watching.